In this video, we'll be looking at problems from section 2.1 and 2.2. Alright, first I'm looking at a problem like number 1. Not exactly number 1, but very similar. Let's say that we have 9x subtract 4 equals 7x plus 20. Alright, in the case when you're solving an equation with variables on both sides, first look to eliminate one of those variables. I'm going to eliminate this 7x on the right hand side. It is a positive 7x, so I will subtract 7x on both sides. 7x subtracts 7x on the right, leaving only 20. 7x minus 9x is a 2x. Alright, so we're looking to solve for x. We want to isolate this variable. Currently 2 is being multiplied by it and 4 is being subtracted from it. I want to undo both of those operations. First I will undo subtract 4 by adding 4 on both sides. 4 subtracts 4 to leave 2x on the left. 20 plus 4 is 24 on the right. Lastly, I will divide by 2 on both sides. 2 divided 2 leaves x on the left. 24 divided 2, that's 12 on the right. X is 12. We could take this 12 and substitute in both sides of the equation, and we would see that indeed 12 is the solution to that equation. Next, I'm looking at problem number 5. We have the equation x squared minus 5x subtract 6 is equal to 0. Alright, this is a quadratic equation and has an x squared. And there's a few different ways that we can go about solving this quadratic. One way is to solve by factoring. So x squared minus 5x minus 6 can be factored into x times x yields x squared. Since there's a subtraction in the second position here, one will be a plus and one's a minus. The product of unlike signs is a negative. We want numbers that will multiply for 6 but will sum for negative 5. That's going to be 6 and 1. Positive 1x and a negative 6x sum for negative 5x. 1 times negative 6 is 6. Alright, this term times this term is equal to 0. We'll use what's called the zero product property. If two terms have a product of 0, one of them must be equal to 0. So separately, we'll set x plus 1 equal to 0 and x minus 6 equal to 0. Solving both of these equations independently, we get that x is negative 1. And here, adding 6 to both sides, we get that x is 6. These are the two solutions to this equation. We could take negative 1 and substitute it back in, and we will see that it yields 0. Also 6 would yield 0. We say that x is equal to negative 1 comma 6. And you can write these in either order. It's not an ordered pair, it's two x values. Alright, I'm looking down now at problems 29 through 45 odd. I'm going to do number 30. This should help you with problems 29 through 45. Okay. It says solve for the variable in question. Our equation says d equals r plus c times t, and we want to solve for r. Alright, we want to get the r by itself. One thing we could do is distribute the t, multiply both of these terms by t, and then we could subtract this term and then eventually isolate the r. But in this case, it might be easiest to first divide by the t. I'm going to divide by t on the right and left side. When we do, the t divides the t and leaves simply r plus c. On this side, we have d over t. Well, I want to get the r by itself, so I simply need to undo the c. I will subtract c on both sides. Subtracting c. I'm going to come over here with the final statement. On the left side, we have d divide t minus c. I'll simply write that. D divide t, subtract c. On the right side, the c subtracts the c to leave the r, and that's what we're looking for. We want to solve for r. Isolate the r. R is d divide t, subtract c. Alright, that should assist you with 29 through 45. We're continuing with our assignment 2.2. I'm looking at page 106. I'm going to look at a problem like number 5. So let's assume that our problem is 4m squared minus 30 is equal to 0. This is a quadratic. It has a squared term, but in this case there's no linear term. There's no simply m to the first power. When that's the case, the process is a little bit simpler. First, we're going to isolate this m squared, get the m squared by itself. We will begin by adding 30 to both sides. When we do, 0 plus 30 yields 30. The negative 30 and the positive 30 add to 0, leaving 4m squared on the left-hand side. Alright, next we will divide by 4 on both sides. I'm trying to get the m squared by itself. 4 divides 4 to leave m squared. And 30 over 4 we're going to leave in that fashion for right now. Okay, once we have isolated the squared term, we're simply going to take the square root of both sides. The square root of m squared and the square root of 30 over 4. Well, the square root of m squared is simply m. And when we take the square root of a fraction, we should take the square root of the denominator and the numerator. So this becomes the square root of 30 over the square root of 4. And we need to look at both the positive and the negative. So I'm going to call this plus and minus the square root of 30 over 4. It's not necessary to say both positive and negative here as well, because essentially we will have some canceling out. To say negative divide negative is the same as positive divide positive. So the square root of 4 is 2. The denominator becomes 2. Well, the square root of 30, well, that's as simplified as it can be. So this is one way to write this answer. Plus and minus the square root of 30 over 2. This is two separate numbers. This is positive square root of 30 divided 2, and it is negative square root of 30 divided by 2. When we have a quadratic, we will oftentimes have two real solutions. Right, that's like number 5. Next I will look at one like number 13. Like number 13. Okay. So in this section it's asking us to complete the square. That is, we're going to add in some constant value that's going to let us write this as a perfect square trinomial. So let's consider x squared minus 10x, and then it shows plus some blank number here, and on the right hand side it's showing open parentheses x, and then whatever this operator is here, it will be the same operation here. Alright, in this quantity squared. Well, to begin with, yes, this is a blank and this is a blank, but we're not saying that these two numbers are going to be the same. This number here is simply going to be 1/2 of the coefficient of x squared. Half of negative 5, half of negative 10 is negative 5. Negative 5 quantity squared is 25. That is the number I'm adding in. Well, the number that's going to go here is simply 1/2 of this number. Half of negative 10 is 5, minus 5 in this case. All right. What I want to show is this is all that you have to do on number 13, but I want to show that these two quantities are indeed the same. Well, x minus 5 quantity squared means x minus 5 times x minus 5. To say something squared, we mean that thing times itself. Well, let's use the distributive property to multiply. X times x is x squared. X times minus 5 is a minus 5x. Now distributing this minus 5. Minus 5 times x is a minus 5x. Minus 5 times minus 5 is a plus 25. Now combining these two like terms, we have x squared minus 10x plus 25. Alright, so this 25 was basically a special number that allowed us to write this expression on the left side as a perfect square, that is, as one binomial factor squared. This process is called completing the square. And we will, in algebra, it has a lot of usages. And the use we will have for it immediately is solving quadratic equations, completing the square. Again, we simply took 1/2 of the coefficient of x and squared it, added it there. This number here was simply 1/2 of that. Half of negative 10 was minus 5. Half of negative 10 is minus 5, quantity squared 25. Alright, that's problem number 13. Now I'm looking at problem number 18. You don't have to complete this even number problem, but this even number problem should help you with adjacent odd numbered problems. Number 18 says x squared minus 2x is equal to 8. Well, we're going to use the process of completing the square. The first thing I'm going to do is write the left side expression as x squared minus 2x and then add in that number that we looked at before. Alright, whatever I do to the left side I must also do to the right side. So in this case we are going to be adding that same number on the left and right side. Alright, half of negative 2 is negative 1. Negative 1 squared is a positive 1. This number will always be added. Since we added 1 to this side, we will add 1 to the right hand side. Now, if we've done this process correctly, we will always be able to write this trinomial as a square of some binomial. Simply take the square root of the first term. Square root of x squared is x. The square root of the last term, the square root of 1 is 1. And this operation will go in the middle. You could multiply this out like we did previously, okay, but x minus 1 quantity squared is x squared minus 2x plus 1. This expression is the same as this. Well, 8 plus 1 is 9. Alright, so now I'm going to put a box around this so that it's not misleading there. We are now, this equation is equivalent to this equation. They have the same solutions. We can solve this one. All we have to do is take the square root of both sides. So, taking the square root of the left side, x minus 1 quantity squared, taking the square root of the right side, 9. The square root of something squared is just that something, so simply the x minus 1 comes out of the parentheses. The square root of 9 is both positive and negative 3. Alright, so we can rewrite this as two separate equations. X minus 1 is equal to positive 3 and x minus 1 is equal to negative 3. That's what this statement means here. It's two separate equations. Adding 1 to both sides. X is equal to 4. And adding 1 to both sides here. X equal negative 2. These are the two solutions. And let's go back up to the original and substitute, and you will see. I'm looking at the values. X is 4 and negative 2. Substituting 4 in place of x. 4 squared is 16. 2 times 4 is 8. 16 minus 8 is indeed 8. 4 is a solution. Substituting negative 2. Negative 2 squared is 4. Then -2 times -2 is also 4. 4 plus 4 is 8. These are both solutions to this equation. With number 18, you should be able to work all the ones through problem 29. Actually, even 33 you should be able to work as well. Alright, that concludes this section.